Welcome. My name is Heather Glenn. I'm the Managing Director of Solutions Delivery here at Blueprint, and we are so excited to welcome you to our much anticipated Expo. Optimization is a growing need, especially for enterprises who use consumption based platforms. While being able to simply monitor cost is table stakes, optimization is about maximizing your investment while allowing your teams to focus on value based projects. Intelligent optimization brings self facilitation to teams in a way we haven't seen before. And today, we've got a jam packed agenda featuring Blueprint's experts in business strategy, tech, innovation, and product. To kick off our expo, I'm going to hand it over to our president and CEO, Ryan Neal.
Thanks, Heather. We are incredibly excited about this expo and the launch of the Lakehouse Optimizer features that are helping organizations optimize their Databricks environment as well as their cloud environment so that they get the most value out of their data estate and their data assets. I want to first say thank you to everybody that is joining us from all around the world today. We have people in attendance from our customer base, from our partner base, from our employee base, and from the technology industry as a whole. So thanks everybody for showing up and helping support our teams in the development of this product. We've done a number of these successful launches in the past, and this is by far the biggest one to date. So thank you for all your support as we continue on with this journey. It's an incredibly difficult one, and I'm so proud of the team and what they've accomplished. We have this journey that where our mission is to help drive velocity and help provide speed to value from the data assets and data estate. And this is part of the journey. I also want to say thank you to the team. We have one of the most special and unique companies that I've ever had the privilege to own in Blueprint Technology. Taking an enterprise product to market in such a rapid fashion is incredibly difficult. Having product market fit and responding to customer needs is incredibly difficult. And it takes everybody challenging them and pushing themselves incredibly hard to understand just what customers needs in the face of all the adversity and pushback. So thank you to the entire Blueprint team for all of the hard work and preparation for this launch. It's been a team effort across the board. We believe that optimization is an imperative, and it should be a starting point for any data and technology strategy. Monitoring and optimization has to be the starting point. This belief is founded in our customers, and they need to get the most value out of their limited resources. One of our clients said it best: if you don't have monitoring and optimization in mind, when starting down the road with any consumption-based platform, it's like driving a car with your gas tank open and your radiator cap off. I'm not saying that I've done that in the past, but he used that analogy specifically with me. So it might have been why it resonated with me. Like I mentioned before, our beliefs are rooted in our customer needs, but today's economy has exacerbated that even more. It reinforces that belief that more than ever, cost of capital has doubled and resources are even more scarce than they were before. The velocity of data and data complexity, data technology changes is moving faster than ever, and companies are struggling to maintain control over their data estates. Data teams need to drive more value to their business, more value than ever. And they need to spend as efficiently as possible so that their technology that they're building, their platform, their practice, and their principles is they create a profit center and not a cost center. We've heard from C-level executives, some of the largest companies in the world around this product. We've also heard from people in the data trenches that are trying to manage these data sources and data systems and data movement. All of them want full visibility into their data platforms and want near real-time alerts and notifications about conditions that are occurring and opportunities for them to improve their platform. We spoke to the head of a FinOps group for one of the super major oil and gas companies. When I asked him what he wanted to get out of Databricks, his data platform of choice, he said, I have no idea because I can't see any of it. I don't have visibility across my entire environment because it's scattered. We spoke to the chief data officer of one of the largest retailers in the world. He's a huge Databricks and Microsoft supporter. He mentioned that cost efficiency and performance efficiency in today's day and age, it's table stakes. Predictability of spend is what he really wants, and especially in alignment with the activities that his platform team is making from an architectural decision standpoint. We also spoke to the head of enterprise architecture of one of the largest financial services in the world. He mentioned he has an entire team of people whose only job is to try to coordinate between their Databricks environment and their cloud provider to try to monitor all the conditions that are happening just on a spend basis and try to provide cost allocation and efficiency recommendations to those teams. And his typical lag is 30 days. That renders those recommendations obsolete. The Lakehouse Optimizer solves all of these problems. And we are so excited for you to hear from our team and from our customers about why they love the Lakehouse Optimizer and why we believe it is a revolutionary new way for you to ensure you're getting the most value out of your Databricks environment. Back to you, Heather.
Thanks, Ryan. Now that we understand the need in the market, let's turn it over to Shannon, one of our solution architects, to dive into what it looks like to add optimization to your tech strategy. Hey, Shannon, welcome. How are you?
Doing pretty good, and you?
Good. Thanks for joining us, especially on your birthday. Happy birthday to you.
Thank you. Thank you very much.
Great. Well, let's jump right in. Shannon, can you help define what optimization means, especially at Blueprint?
So if I was a data scientist, I'd probably give you an answer, something about how optimization is the process of finding the best solution or configuration for a given objective. Optimizing a solution, generally it requires efficient and effective methods to analyze, model, and interpret your data relative to that objective. But I'm a solutions architect, so when I'm working with organizations and we're talking optimization, they're always asking, how can I save time? How can I save resource? How can I save money? When they're talking about time, they're up against some SLAs. Code's taking longer and longer to run as their data grows. They want to find ways of beating SLAs. When it comes to resources, I've had customers where they're in a data center. It's just got limited capacity, and that data center has no desire or plan to grow those resources. And then finally, money. We all know what money's all about. You want to save money and get more with less.
Absolutely.
So at Blueprint, we understand optimization starts with setting that objective, discovering what data relates to it, and ultimately taking some action based on that data and what it tells us.
Awesome. Thanks, Shannon. One of the questions we get a lot is, what does it actually look like to add optimization to a company's tech strategy? Can you help unpack that for us?
Sure. Yeah. So pretty early on in my career, I got to work with some great guys from the armed forces, Marines mostly, and they taught me about the OODA loop: observe, orient, decide, and act. So, when you're deciding to optimize for something, you begin by observing what's happening. So going back to the data, you got to set up monitoring. You got to set up proper monitoring to pull in the right data. At a bare minimum, nowadays, we're talking about those 4 key resources: CPU, memory, storage, and network. That's at a minimum. And once you've collected that data, you move on to the orient step. You want to start contextualizing the information that you've gathered. You want to correlate that data, and is it a positive indicator or a negative indicator for a desired state? You'll start building reports to help you understand that data and how it impacts the outcomes for your specific goal. Once you understand what's happening and how it affects your outcome, make a decision, decide, and act on it. And once you've made your change, start it all over again. Go right back into the OODA loop. So whatever tooling you do choose to aid your optimization, it's got to enable all 4 steps. If you can automate those steps, automate gathering the data, automate report building, automate optimal decisions, that's great. But at the very minimum, you got to automate that monitoring. And if so, then it's up to you to build tools that help you orient and decide and act.
Thanks for that, Shannon. As a follow-on question, how do you measure the impact and effectiveness of optimization in a company's tech strategy?
Sure. So the specific metrics, they're really going to depend on the objectives. So let's go back to the time, resource, and money. If you're trying to optimize for time, you monitor your SLAs and record how far over or under you are. Plot that over time. You'll get your trend line telling you, are you properly optimizing for time? If time's going up, you're failing. If time's going down, awesome job. If you're optimizing for resources, basically you track consumption by unit and by time. If you see your resource utilization going up, not so great. If you see it going down, awesome. You can always break that down into infinitely finely grained data. And then if you're optimizing for money, spend over time. It's a pretty easy metric. There are some harder metrics. So cultural impact, what does it mean to change from just spend to let's optimize our spend or optimize our resource utilization. Basically, you just tracked activities. You can capture, how often are new resources spun up, how often are they turned off. Are people self-governing or not? When optimizing for time, it's really hard to tell how optimizing for time affects your team, other than maybe checking out the data coming off their smartwatches, looking at their blood pressure, heart rate, and things like that. I mean, it can be done, but really you just got to look at your team and see, are they being effective given the resources they have at hand? And when it becomes a standard practice, you'll see it reflected in their calendars, DevOps boards.
Sure.
The metrics are there.
Awesome. Okay, Shannon, final question for you. How can tech leaders truly have cost predictability when it pertains to a tool like Databricks?
Well, first and foremost, you've got to have visibility. You've got to have enough visibility that you can get around that decision paralysis. So it's more than just metrics. It's wrapping all of that up into a single pane of glass, so you can take action and continue to optimize over time. So we know this is important to a lot of our customers, not just with Databricks, but with any consumption-based platform. Getting cost predictability, it's not a given. Resources need time and money to make that happen, to make optimization a part of development. And the same way testing is just a part of your development strategy. You've got to invest in tooling to enable the process, and you've got to encourage the process of optimization across all your teams, not just IT. I mean, everyone needs to be invested in this. So, with the right approach, you can move from that reactive reporting to forecasting. With forecasting, you can take advantage of committed purchases, like Azure and Databricks offer with DBUs. And then from there, you get to that cost predictability that you're looking for.
Thanks, Shannon, for joining us. Your insights were helpful. Let's turn now over to Gary, who will explain what it means to truly have an intelligent optimization solution. Gary, over to you.
Thanks, Heather. Hello, everyone. I'm Gary Nakanalua, and I'm the Managing Director of Innovation here at Blueprint. This is the day that I have been excited about for the last year. In our lab and across the company, we experiment so we can facilitate organizations through the technology revolutions that will come 2 to 3 years in the future. At this year's Data and AI Summit, Databricks CEO Ali Goldsey noted that innovations don't become technology revolutions until they're democratized. Now, for organizations that have made the investment into a lakehouse for your data estate, you understand the architecture is designed with democratization in mind. This democratization unlocks the horsepower necessary to solve some of the stickiest business problems that have plagued organizations for decades. However, this horsepower introduces new challenges. I'm a car enthusiast, and I funnel that enthusiasm into a Dodge Challenger Hellcat, modified to output 800 horsepower, getting from point A to point B quickly, and at times loudly, provides a significant level of personal value. However, that speed demands that I monitor every aspect of that beast and tune it consistently and appropriately. In short, I optimize my car for value. Now, this optimization enables me to effectively unlock additional horsepower. In fact, I am on a path to get to 1,000 horsepower. Now, along the same vein, optimizing its lakehouse empowers an organization to allocate investments effectively and discover solutions to other problems within additional use cases. Put quite simply, Lakehouse optimization unlocks the ability for organizations to do more with more. Now, here at Blueprint, our mission is to deliver the right data to the right person at the right moment, because we believe that intelligence matters. Starting out, our Lakehouse optimization solution provided monitoring capabilities, delivering key insights to personnel within an organization via dashboards and incident alerts. However, today, we consider these insights as table stakes. Over the last year, partnering with a variety of customers across multiple industries that include energy, manufacturing, finance, and retail, we have evolved our Lakehouse optimization solution. That's why I'm excited to share that today we are launching a variety of new intelligent features for the Blueprint Lakehouse Optimizer, features that drive decisive, self-facilitated action for every facet of your organization, designed to drive the most value out of your Databricks environment. For business leaders responsible for financial operations, gone are the days of surprises when you received a monthly bill for your Lakehouse cost. Now, you have intelligent forecasting that provides a financial outlook of your historical and current Lakehouse spend in comparison to your budget allocation and pre-purchase commits. We also introduce organization mapping, the ability to directly correlate Databricks spend to specific departments, teams, and initiatives. For leaders responsible for driving the most business value out of your Lakehouse, you no longer have to worry about whether your organization is utilizing the platform effectively. Now, you have intelligent recommendations, immediate actions you can take to optimize your Lakehouse for efficiency and performance. And finally, knowledge workers, those that are responsible for the creation and maintenance of analytics workloads. Now, you can focus more on engineering and less on troubleshooting orchestration issues. With the new features released today, you have intelligence into pool usage, resource contention, and auto-scaling performance. All of these features and more are available to you in the new version of the Blueprint Lakehouse Optimizer. And in a few moments, you will get to see firsthand all of these features in action. But first, Heather, back to you.
Thanks, Gary. At Blueprint, as Gary just referenced, we pride ourselves on delivering intelligence that matters. This solution focuses on just that by maximizing value, eliminating waste, and enabling self-facilitation. Now that you've heard a good deal about the challenges and needs we're witnessing in the market, let's shift and take a look at the Lakehouse Optimizer. The Lakehouse Optimizer is a cutting-edge tool that monitors Databricks environments. It identifies issues in data pipelines, it provides intelligent recommendations, and it improves performance and reduces cloud cost. The following demo is led by Michael Halleck, our Director of Product Sales. So let's get our first look at the tool. Over to you, Michael.
Welcome to the Lakehouse Optimizer for Databricks. Here we are on the overview page, which is essentially our starting point for our optimization journey. Organizations will use this as their admin console to properly steward their Databricks environment from all levels of the Databricks hierarchy. Executives who own a Databricks deployment struggle to make the best decisions to enable the business because of inherent complexities of the platform. They'll find that they have essentially zero visibility to tie in both Databricks and the cloud spend, as well as zero visibility into understanding who is using what, where the issues are, and what to do about it at an actionable level, which results in zero predictability, leading to decision paralysis, and leaving not only money on the table, but leaving business progress on the table as they cannot onboard additional use cases. It's the best way to drive more value from your Databricks investment. And so here we are going to start with just that. We have an organization that is already consuming their monthly commitment that you see there in the pink line, but they are trending underneath their budget. However, we can see from our intelligent forecasting feature that if the user does not take into account the spend trends that are occurring without optimization, they will end up exceeding their monthly budget levels. However, if they're able to take into account the optimization recommendations that are going to come out of the platform, then they can identify how they can be very prescriptive in their actions to reduce their spend, get the environment back under control, and ensure that they have enough capacity to onboard additional workloads to the platform and use it to the best of their ability. We're starting here and seeing the total cost of ownership across the Databricks platform, both for the cloud provider. In this case, in this example, we are highlighting Azure. We also have an AWS version as well. They can filter this down to see the Azure spend with specific monthly budget and monthly commit numbers, as well as the Databricks spend as well. Additionally, as it relates to our Executive Insight Engine, one of the new key features that have been released as part of this launch, we have the ability to map the organization both on the cloud provider side as well as on Databricks, importing tags from both sides of the cloud and providing a nice handy interface to be able to help understand where the business is consuming what, where the unhealthy spend is, and exactly what to be able to do about that as well. Here we're highlighting particular business units that have been tagged. This is very beneficial for shared service models where you need to have a chargeback model that allows you to identify at a very granular level who is actually using what in the organization, but it also can be used to serve up specific business processes or workloads or individual use cases, and even particularly IT-oriented projects. However the organization wants to map and track this information, you have the ability to do so with the Lakehouse Optimizer. Drilling in here within supply chain, you have a similar view as we were looking at before. We can identify what the total spend is for this particular business segment, month-over-month change, individual budgets for this part of the business, and similarly speaking, healthy versus unhealthy spend broken down in some key areas that allow you to take action, and the intelligent forecasting that is going to allow you to identify how things will continue to go on as they are unchecked, and what your future can look like when you follow the prescriptive optimization recommendations that come out of the platform. On the right-hand side here, we're also breaking down the key features that are being leveraged from workflows, all-purpose clusters, Delta Live tables, pools, and SQL warehouses. Each one of these underlying features have a great deal of granular telemetry that we're collecting in near real time, which allows you to make optimization decisions at runtime as users are actually engaged with leveraging the platform, but then also to be able to see it all up in aggregate to help facilitate the planning and budgeting type requirements that the business also needs to be able to fulfill. Over here, you can see that we have a number of incidents that have been listed here on our set of all-purpose clusters. We'll also show what the dollar amount is of the consumption of those resources and the number of resources as a whole. Drilling into the individual recommendations, these are served up by our intelligent recommendations engine. We'll provide very specific estimated cost savings and very prescriptive recommendations to be able to take action, identifying in this case individual clusters within particular workspaces, identifying in this example some exact idle numbers. And if you drill in, it will give you some more information about the shutdown periods and some other recommendations that can actually help you fulfill those estimated savings. We have another area that provides some additional granularity into that, and we'll drill into that here in just a moment. Center of Excellence leaders will greatly appreciate their ability to understand how each one of the features and components of the platform are being rolled out and being adopted by different segments within the organization. That way you can quickly identify if there are areas, for instance, SQL warehouses, if they expected more usage or more consumption in that area, you can go to the supply chain group and then begin to have a conversation about up-leveling and enabling them to be able to leverage the platform more effectively, catch up in their requirement for onboarding additional use cases, and ensure that they are using it properly and appropriately, ensuring that there are a minimum number of incidents and a minimum number of recommendations in order to make improvement. I'm going to go back up a level, and And we're going to drill into the optimization health scores here as we identify what we are describing as healthy spend as well as unhealthy spend. In this particular environment, we have a lot of healthy spend, which is great. Organizations that are already en route to providing an optimized environment can congratulate themselves for doing a good job already, but there's still more work to be done. We have 3 key areas for our optimization pathways that we like to highlight. We describe them as efficiency, performance, and orchestration. Each one are going to have very distinct actions and recommendations that are driven from the lowest levels of granularity within the platform, and then aggregated up here so that you can actually summarize and understand what you need to be doing in mass. Taking a look at our efficiency score, for example, this is where you start to find some very specific recommendations to be able to take those unhealthy spend figures, minimize them, and take complete control over the environment. Here you can see, for example, one of our key areas, we have a particular pool that is composed of a number of idle VMs. We've identified the VM type, the number of idle VMs, and a specific recommendation to change the maximum VM count to save, in this case, to over $2,000. There are a number of other recommendations that are also generated as we look at the breakdown of unhealthy spend. We'll look at over-provisioned workloads, idle cluster instances, and in the example I just provided, idle VMs and pools as well. By providing a tally of the number of workloads, clusters, and VMs respectively, you can get a better idea of the size of the problem. And then by drilling in this view workloads or view clusters or view pools area, the data practitioners can start to take very specific action filtered down to the context that they need to be able to not only understand the summary of the recommendation that we've provided, but also validate and substantiate it against their context or additional intelligence that come outside of the platform for what the business needs and whether or not these recommendations are going to fulfill those requirements. It allows them to essentially personalize this information to the business and then take action where appropriate, again, to minimize the level of unhealthy spend. I'm going to go back out one more level too and talk about their orchestration recommendations a little bit as well. This is a very novel way to be able to look at health of a Databricks environment. Essentially what we're doing is we're looking at the startup versus the runtime of workloads. And all you don't necessarily is very healthy. In this case, we'll identify very specific workloads that are grouped within segments that you can actually take action upon. Up here in that first recommendation, we found workload group A has 309 of a very particular instance type. If you group these workloads and set up dependent workflows, you can save over 25 hours of time and $700. There are additional workloads that we can group together to be able to minimize the amount of startup time. What we have found out is the cloud provider side, you're essentially paying for a few minutes every time one of these workloads gets fired up. On the Databricks side, not all of that startup time is being consumed. It's about a minute for each. But as you look at this across the entire enterprise, there becomes a lot of savings that can come to bear just by grouping workloads appropriately and ensuring that we minimize that amount of startup time. The net result is also being able to pull the SLA for workloads forward. So if you have regular reporting requirements or data that needs to be delivered for a customer or another part of the organization, you have the ability to run that more frequently, deliver that data earlier because we've minimized the amount of startup time that has occurred just by grouping and providing proper orchestration patterns. Rolling back up to the top, I just wanted to quickly summarize some of the key capabilities here as it again relates to our intelligent forecasting feature, allowing you to identify where the best level of commitment is, how you are trending against your budget, and being able to ensure that you can get the best value and at the most appropriate level of discount for the type of spend and consumption that you have. Organizations that have a high level of confidence in the health of their environment, as we look at the optimization health area, which is part of the executive insights engine, will have a great deal of confidence to ensure that they are committing at the right tier for the right amount of spend and the right amount of value that is being able to be provided to the organization. And then lastly, of course, we discussed our intelligent recommendations layered underneath each one of these areas. What I'm not showing you is the opportunity to drill into the most granular levels of telemetry. We have another session which we're going to describe things like pool contention reporting, auto-scaling insights, even identifying the individual auto-scaling segments of time and the things that trigger that and the kind of actions that you can take there, among another set of vastly productive recommendations to be able to help both the executives, directors, and data practitioners alike come together and ensure that the Databricks environment is as optimized as possible and best set up for the organization to have the most impact through the workloads that are being run. Thank you very much.
Wonderful. Thanks, Michael. Now, before we dive deeper into the tool from a technical perspective, let's pivot and catch up on one of our customer stories. This tool is being used across many of our customers today. We've seen it save, on average, 30% on a customer's total cost of ownership, and it's helped improve Lakehouse performance on average of 50% per customer. Now, that's some serious ROI. We'd like to showcase one of our tech-forward customers, Dan Shah from IGS Energy. IGS is an energy retailer with a goal to build a more sustainable energy future by allowing their customers to choose the right energy for them. They offer 100% renewable electricity, carbon neutral gas, and solar energy systems, to name a few products offered to more than their 1 million customers. We had a chance to sit down and catch up with Dan and ask him about his experience since using Lakehouse Optimizer and his time working with his team at Blueprint. Let's listen in on their story.
Dan Shah, I'm manager of our data science and engineering team at IGS Energy. What our team's responsible for is taking any data that we have and making it more useful for a company, specifically using machine learning and artificial intelligence to accomplish that mission. One of the reasons we chose Databricks is because for our core workload, we're forecasting energy needs for our customers well out into the future. And this requires transformation and loading and transformation and prediction on large quantities of data. So every couple of weeks, we're training hundreds of thousands of models, and Databricks was a great platform for that kind of production workload. The biggest challenge was cost visibility. For us, we reserved Databricks units, so DBUs, and then we pay as we went for Azure VMs. And to be able to see, it was impossible for us to see both of those costs. So it was really kind of a black box for us, and unless we cobble together a bunch of raw data at a high level to understand where we could reduce costs. So we engaged with Blueprint to try to bring together our reservation costs, so our Databricks costs, but also our Microsoft costs, so VMs and storage, in one spot, so we could try to determine where our workloads maybe are inefficient, but also which workloads we needed to improve or change. Should we change the type of job? I mean, one of the first things we saw when we started leveraging the Blueprint tool is we had streaming jobs that were costing us $50,000 to $60,000 a year. But our downstream teams did not need real-time predictions. They needed it at one point during the day. So we converted those to a batch job. And that saved us about $50,000 right off the bat. This was within a month of deploying the tool. So like performance data in Databricks is only available for 30 days or a little bit beyond that. Now with the Lakehouse Monitor, this data is available to us, as long as we keep the storage of where it's housed, so forever into the future. This allows us to see jobs not over days, but over months and years. Being able to see like how expensive a job is, but also like within these jobs over time, we've got performance data now, we've got cost data. So that's been the big power to us is just being able to understand all the costs in one spot and also persist this over time, so we can see like how our improvements are changing costs, but also like when do we need to intervene with a specific workload. Another change is if we had a job schedule to run daily and we realized it was at a certain cost, we can put that cost in front of our downstream teams and say like, hey, are you getting this kind of value out of this job, or should we run it less frequently? Which has been been a big help for us. The other thing too, which is kind of different than like us tuning our jobs or changing the hardware runtime or changing like the configuration of the job, has been allowing citizen data scientists to come into the Databricks platform more easily. So, we have governance set up. In terms of cost governance, the Blueprint tool allows us to see when are we over provisioning resources for their citizen data scientists, when are those jobs less efficient, what are the costs. So then we can kind of have an understanding of, like, as we bring these folks into the Databricks platform, when do we need to intervene in terms of how the jobs are running, or just educate those folks in terms of how to leverage the Databricks platform. So that's the big capability for us, is now we can develop more proof of concepts because citizen data scientists, we feel more comfortable bringing them in, because now we have a handle on what are the costs associated with their specific workloads that we're developing. We can share these results with the leadership team, and they have more confidence that we have the governance in place to keep costs under control, and that we're doing the right steps to bring these costs down. The optimizer helps us, one, understand what the costs are, but two, tune the cost. So in the future, when we have to talk about what do we expect a workload to cost relative to the value it brings to IGS or to external partners in the future, we have to understand what the costs are. I think a lot of data science workloads fail today because there might be an upfront labor cost that's somewhat easy to estimate. What are the cloud costs going forward? If that's opaque, it becomes really hard for an organization to try to determine what is the value, total return on investment for a workload. When we talk about future workloads, I don't want our engineers spending a whole lot of time cobbling together data to try to understand costs. That's where this tool is really useful, is that we were able to save time and try to understand different components of workloads like performance and cost much more quickly. That's powerful for us because then we can spend time developing other solutions. The cost going down obviously means we can offer it at a more competitive price to our customers. But also, when we're not spending time trying to understand those costs, we're adding value in other ways to the company. So it's kind of twofold. It's one, we can reduce the cost of making this data more useful for internal partners, external partners. But also, we're not spending time trying to cobble together these costs and answer questions about, why was our cost last month a certain level? We have all those answers in hand within clicks, which is really, really powerful. The team has been amazing. So, we worked with third-party or with vendors before, and one thing that stuck out to us about Blueprint is the technical capability of the team. They know Databricks in and out. The team has this pays attention to UI and how we're leveraging the application, and they're continuously iterating to improve it, which is powerful. So it's been an absolute pleasure working with the team because they listen to our feedback, and we're continuously seeing the tool update and include new features that we're excited about. So it's been a great collaboration, but it's also just been really exciting to see the tool evolve. One, in frequency, but two, just in usability. It's a really friendly user interface. So yeah, we appreciate the opportunity to work with Blueprint, and really appreciate Blueprint taking the feedback from our team as this tool has been updated over the year and a half, I think, since it was deployed.
Thanks again, Dan, and the entire IGS team for letting us tell your story. I'm going to turn it over to Claudio, our Director of Engineering at Blueprint, for a deeper dive into the tech behind this tool. Claudio, over to you.
Thank you, Heather. Claudio here. I'm the head of product engineering at Blueprint. Super excited to do a technical deep dive into the Lakehouse Optimizer. I'm going to share my screen here. So here I'm sharing the screen to our demo environment Blueprint. This is a national deployment. It'll be similar for AWS. The overview page shows us the environment from three different lenses: efficiency or waste, performance or latency, or orchestration. Efficiency and waste is the cost in dollars I'm wasting in my environment, unhealthy spend. I'll go back to September, full month. The performance is really the time to insight component. How fast am I running my jobs? And the orchestration is really the effort of scheduling all my workloads that obviously help me with both the other two components, time and money. So how do we go about solving these problems? Now the tool shows me a summary. Let's pick efficiency and waste because it's easiest to tackle, right? And it comes from three different sources: pools, idle VMs in pools, idle time in clusters, and over provision workloads. If I go one level deeper into the tool, I'll see the cost per workspace breakdown, distribution by feature, job cluster, all-purpose compute. The sixth item on the list is idle VMs. We typically see high values here with every customer we talk about using pools. They're using pools to reduce the startup time of workloads so they can have that time to insight, right, component optimized. But if it's not properly configured, it creates a lot of waste in the number of idle VMs, which obviously associated with dollars. So this is where we look on day one to see if there's issues with the pool configuration. So let's dig into that, the first component. If you go to the workloads area, there's workflows, all-purpose cluster, Delta Light table, SQL warehouses, and pools, right? So we'll start with that. And I see that I have a list of pools in this workspace. I'm picking this one, executors, and I know that, like say, for example, if I did this, I found a spike, one of these days, right? The tool will find the spikes automatically for you. I can drill into that, zoom in on the screen, and really find what the issues with that pool and the usages of that pool by all the concurrent workloads during that time. And I see that solid colors are clusters, workloads. Could be all-purpose clusters or job clusters, or DLTs for that matter. And then for each one, I have a auto-scaling timeline. It's the number of VMs in time. Right? On the left, on the y-axis, I have the number of VMs. X-axis is the time components. I have 3 workloads starting. I have the name of the cluster, the job, everything I need to know about it, start, end, and how long it took, how many VMs it required from the total. And what I'm seeing is if I have too many clusters asking for VMs in the same time from the pool, basically in contention mode, the VM count increases. The higher the VM count, the higher also the idle VM count. And that's because now the pools are configured with a timeout, with a shutdown timeout. VMs are returned to the cloud in 12 minutes unless another cluster picks them up. If no other cluster picks them up, they're going to stay idle in the pool. Now I'm seeing here a period of 4 minutes, 45, 12 VMs, just completely idle. Nobody picked them up because the first cluster only started later, right? So how do we reduce the waste? Now this shows me how I can reduce it with the 3 approaches. One is to change the configuration of the parameters of the pool, the minimum idle and the shutdown timeout. Another one is to reschedule, to reorchestrate your workloads so that you reduce the VM count. Basically, shift them to the right, delay them a bit if you can, if your business allows you to do that. And then you reduce the maximum VM count, which then naturally reduces the idle VM count. Or relocate your workloads in another pool, like create another pool. It's really easy to create one and move them over there. That's how you basically reorchestrate and you reduce again the VM count. All-purpose clusters should not be in the same pool with job cluster, for example, because of different usage patterns, right? So those are my workloads. That's the approaches to help to reduce the idle VM. Now, if I click on one of these workloads, like I said, we stacked up together all the scaling timelines of each cluster. That's how we know how many VMs were used. And if I go into the detailed view for this job run on September 28th, I have this auto-scaling timeline available, and this shows me how my cluster consumed VMs from the pool. Now this is the segment of 4 VMs for the duration, start, and actually even the cost of that. So for 10 minutes, 4 workers, 4 VMs for the cluster nodes, and that was the cost. The auto-scaling timeline in this case shows me there's a bit of a change in VM count. Every change in VM count, every auto-scale event here is going to cause some delays. So I have to look back at my workload to see if it's actually really useful to have auto-scaling, or maybe I'm just better off with a flat line, fixed size cluster, because most of the time these small 2 node segments are like 45 seconds, almost like it's not even worth to keep auto-scaling in this case, right? What we've seen bigger problems here is we have workloads that are calling out external services. Databricks cluster is up, calling another workload from Snowflake, BigQuery, another compute engine, or calling external APIs that are taking a long time to build something, right? Or even doing something on the driver. Maybe all of a sudden I collected my data on the driver. I'm doing something on the driver, Pandas data frame workload. Obviously, the cluster will see a flat idle a flat line here in the auto-scaling timeline. That's an anti-pattern for using the cluster, right? External services should be reorchestrated in a way that when you use a cluster, use it and then decommission it. So that's an anti-pattern that the auto-scaling timeline picture will give us. Now calls to external services, they should not be orchestrated mixed with the Spark workloads. They're supposed to run in a cluster, right? So that's the auto-scaling timeline. Back to the type of ways that we have in an environment. I talked about idle time in all-purpose clusters. And if I look at this, I see the all-purpose clusters in this workspace, and I see the active versus idle time, right? How much is that all-purpose cluster up for, and how long it's actually being used by workloads? And it looks like the 77% of this cluster, 19 hours, actually was idling. Idle means there's no Spark activity in the cluster, or the CPU is lower than 3%. That's configurable, obviously. And immediately, the first step to solve this problem is you're going to get them in the incidents area, and if I'll filter by all-purpose cluster, I'm getting all the incidents. Shutdown timeout above threshold, right? So the easiest way to fix the idleness in the cluster, all-purpose cluster, is to reduce this shutdown timeout, right? At the end, it's spending 45 minutes every time you start it before it stops, when really the minimum data breaks is 10 minutes, and the configured threshold in LHO, you can change that, is 15 minutes, right? So the easiest way to reduce idle is just to look at these numbers. We've seen default numbers in the thousands of minutes, right? So that's not a good thing. So that's how you reduce the, it's the easiest way to reduce the idle time in a cluster. There's other ways. For some other time, we'll have another follow-up of those. Over-provision workloads, I want to touch on that. So if I look at my workloads here, let me pick something from last month, this now demand forecasting multi-site job. I'm seeing that it has 7 incidents. It's a multi-task workflow, 2 tasks. Each task has 3 nested notebooks. I'm going to look at the incidents because they show me to me. So I see they have 2 clusters basically. There are 2 clusters used for those for this job run. Very likely each task runs in its own cluster. And I have more than one event. I have cluster CPU over provisioning, memory over provisioning, driver memory. So there's a lot of issues with this. So you have the explanation here, the thresholds that were exceeded, the CPU or the memory amounts. And then you have recommendations on how to fix that immediately. And then, for example, for the first set of problems, we're telling you that we should downgrade your driver to an instance of this type, right? Standard F4, 4 cores, 8 gigs, and so forth. So we give you the list of instances that you can use to basically reduce that over-provisioning. Over-provisioning means too much CPU or too much memory allocated to your cluster. And you can see that immediately in the data points. I'm picking the first task, and I see that there's only cluster memory, only at the maximum 4.27%, right, of that cluster. Let's see, that's not a good idea. So it's 14 gigs on the nodes, 6.5 on the process on the JVM, and I'm only using 276 megabytes. Clearly over provision. You can obviously go and use a much smaller instance type and save a lot of money in the process, right? So that's the data points that are available here for cluster memory and CPU. And let me pick another example. I'll show you what we have a full cluster, the train job. I believe we'll have that. Yeah, this one. So let's look at the CPU for this, the cluster memory. There we go. So this is a multi-node cluster. You have each one of them is 8 gigs. You have the memory on each one of them on each node, the max and average. But there's also the full histogram of this cluster, both memory and CPU data points available in the LHO database. That if you want to look deeper and find out if you have CPU bound or an hour bound job that can be reconfigured differently, right? So it will help you with that part of the optimization process. So that's what I basically wanted to show you in terms of how to fix the efficiency or the waste part of your environment. Reach out to find out more. And for now, this concludes the technical deep dive of this presentation. Thank you so much. Back to you, Heather.
Awesome. Thanks, Claudio. All right, with that, folks, are you ready to kick off a free trial? You've heard from our team on why optimization is so important today, how you can implement improvements to your tech strategy, and more importantly, how helpful and impactful an intelligent optimization solution is for Databricks customers. If you have questions or you're ready to move forward in scheduling your free trial of the Lakehouse Optimizer, contact us now at info@bpcs.com, also shown on the screen below. Our teams are connected. Our teams are ready to connect with you and are standing by. Thank you so much for joining us today. That's all from Blueprint, and we look forward to connecting with you soon. Bye for now.